What is this called?
Exponent.
What is the 3 called?
Power.
What is it? It's a base. So 3 is a base. 2 is an exponent. Or sometimes we call it a power. So that's just some basics right there. You need to know that in order to solve these problems. Would you start writing? Would you start writing?
Can't we just look it up on the thing? Yeah.
You don't even have a Facebook.
Here we go. So, I'm going to have problems that look like this.
Joy.
So what I want you to recognize about these is they have the same,
Base number.
so these are same base problems. Excuse me. Yes. No, that's definitely not correct. Maybe it is, I don't know. Same base, we're going to, this is really easy, add the exponents. Keep the base. So if I'm going to add these exponents and keep the base, what's my base going to be? It's going to stay as a 3, and I'm going to add the exponents. 4 plus 2? 6. Now you can leave your answers like that. I'm not asking you to multiply 3 times 3 times 3 times 3 times 3 times 3. I already know that you know how to multiply, so you don't have to prove that to me. You can leave your answers in exponential form like that. But what you can't do is leave negative exponents, and we're going to talk about those. All right?
Do you flip it?
So let's try another sample problem question.
Is it possible to do like different bases with the same exponent? Do those show up?
Nope, those will not show up right now at all. So here's another problem that we're going to try. We're going to try like this, like 5 to the negative 6 times 5 to the 3rd. Let's try that one.
That would be. Oh my god, that's confusing.
Not really.
Yeah.
You need to turn the 5 into 1 over 5.
Let's leave it right now.
5.
This is same base, correct? The base in this problem is 5. We're going to add the exponents. What's negative 6 plus 3? Whoa. Negative 3. So this problem is 5 to the negative 3, which we're not going to leave it like that. It's going to convert to JT.
Negative.
5 to the negative 3 is equal to?
1 over 5.
So this is 1 over 5
3.
to the 3rd. Now I'll accept that answer. That's fine. You do not have to multiply your powers out, okay? Unless it says multiply your powers, you do not have to.
But that would be.
Let's try one more sample problem like this, I think. Question?
What if they're all the same?
Then we just leave them. Then don't worry about it. They will all be the same base. Let's try one more. Let's try like 7 to the negative 2 times 7 to the negative 8. I don't know. Base is the same? Base stays the same. So I'm going to continue with a 7 to the
What?
to the negative 10, which is equal to
70.
1
over 7 to the 10.
over 7 to the 10th. That's your answer. That's good?
That's easy.
It's all good, yeah.
Okay, then I have one other type of problem I'm going to show you. Then we'll do a couple more samples and you guys will be good to go. The next type of problem is called a power to a power. So these problems are going to look like, yes,
Power on power? Question.
power to a power.
Do you, like, that one, not the power to the power, do you just change the sign, like, when you make it into a fraction?
Remember what's the rule for negative exponents? Flip it, go positive, remember? So if I end up with something to a negative exponent, remember I put it over 1. Remember I had stuff like this? This can go away. I don't need this anymore. Okay, so remember if I have like negative exponents, I had something like this, I had 9 to the negative 2. So what did I do with this? I turned it into a fraction, so I go over 1, and then flip it, go positive 1 over 9 squared. Alright, then I also had problems that looked like this, like 3 over 2 to the negative 4. Remember this, the exponent went to everything. So this became 3 to the negative 4 over 2 to the negative 4. And the rule again?
And then flip it go positive.
Flip it go positive, so this became 2 to the 4th over 3 to the 4th, and that was the answer to that, right? But in the past, you've been actually multiplying all these out, you don't have to do that now. So power to a power problems are gonna look like this. It's gonna be like a base 5 to the 3rd, how about squared? So this is a power to a power. I have a power inside the parentheses raised to another power. So power to a power. Power to a power. What are we going to do with those? We are going to, we're going to multiply the exponents.
So then
So
it
a
would
couple
be
sample problems and we'll be
5 to
good
the
to go.
6th power.
This would be 5 to the 6th power. Thank you. Cheerleader number 2. 5 to the 6th power. Okay. I just have to do a couple sample problems like this, and then I think that you guys will have an example of